Let's solve another pair of simultaneous equations using the method of elimination. Now, we have 3x plus 2y equals 12 and 5x plus 7y equals 31. Let us call the first equation EQ1 is equation 1 and second equation 2. Alright, now we want to use elimination, and the purpose of elimination, remember, elimination means to get rid of, and we want to get rid of one of the unknowns. Each equation has two unknowns. You can work with one equation at a time, but you can't really solve the equation if there are two unknowns. You need one unknown, so you need to eliminate one of the unknowns. Equation 1 has the two unknowns x and y. Same thing for equation 2, two unknowns x and y. Now, you can always add two equations or subtract two equations in order to form a new equation and to see if that new equation has only one unknown. Alright, so let us try to eliminate x or y. X first, by adding equation 1 to equation 2. If we do that, we would have a 3x plus a 5x equals 8x. Doesn't work. We cannot eliminate x by adding these equations. So let's try eliminating x by subtracting these equations. 3x, are we trying equation 1 minus equation 2? 3x minus 5x gives you a negative 2x. Okay, we cannot eliminate x by adding or subtracting the equations. Suppose we try y. Let's try equation 1 plus equation 2 and try to eliminate y that way. 2y plus 7y equals 9y. We have not eliminated y by adding or subtracting equations 1 and 2. Let's try do it. By adding equations 1 and 2. Let's try do it by subtracting equation 1 and 2 now. So equation 1 minus equation 2. 2y minus 7y. 2y minus 7y gives us negative 5y. Okay. Problem here. We cannot eliminate x or y by adding or subtracting these equations to form a new equation with one of them eliminated. So we have to go to another strategy, the next strategy in line. Let us see if we can form a new equation, let us say with a 3x in it. If we can form a new equation that has a 3x, then if we have a 3x down here, then we could take this 3x up here and this 3x down here and subtract them to get a 0x. So if we do that, what we will have to do is multiply equation 2 by a certain number. Now 5 times what gives you 3x? know that 5 times 3/5 will give you 3x, because 5 will cancel 5. So the number that we would have to multiply by is 3/5. And we'd have to say 3/5 times 5x. Right? 5 would cancel 5 and give you a 3x. But we would have to multiply the 3/5 plus the 3/5 by 7y. And we'd have to say equals 3/5 times 31. But guess what? This would have 3/7 21 over 5y. And this would give us, this part would give us 3 3s 9 3 1 93 over 5. But then we would have to take this 3, subtract from this 3. We would have a 0x, but the problem here now would have to be having fractions, adding and subtracting fractions. That would make our life a little more difficult and complicated. We don't want to deal with fractions. Let's forget this and not having to deal with fractions. Let's use another strategy. Let us say we want to eliminate x. We want to eliminate x. Suppose we multiply 5 by 3. We would get a 15x. And if we multiply 3 by 5, we would also get 15x. Then we could subtract these 15x and get 0x. Wouldn't that be nice? Now, let's try that. If we do that, we would have to say we're going to form a new equation down here by multiplying equation 1 by 5. If we multiply equation 1 by 5, we would have to say equation 5, this 5 multiplied by 3, because we want this 5 times 3 to get 15. That's why I multiply by 5. But if we multiply this by 5, we'd have to multiply this by 5 and this by 5 as well. So we say 5 times 3x gives you 15x. Right? Plus 5 by 2. Y. 5 by 2y gives you 10y equals, then we'd have 5 by 12. 5 by 12 is 60. You see that? So that is equation 1 by 5. Now let's try equation 2 by 3. We multiply equation 2 by 3 because we want the same 15x under this 15x. Right? By the way, let us call this equation 3. Okay, let's go back to what we're doing now. 3 by 5 gives you 15, because we will have these 15 x's where we want them. Then 3 times 7 would give you 21y equals, then 3 by 31, and that would be, that's 3 3s 9 3 1 3. Alright, so 93. Let's call this equation 4. Now we have this set up just like how we want it. Right here is going to be where we eliminate x. So what we say is equation equation 4 has bigger numbers. Let's say equation 4 minus equation 3. We could have said equation 3 minus equation 4, but we would end up with some negative numbers. And with the negatives, you probably might make some mistake along the way with the negative signs. Let's just keep positive signs by saying the bigger numbers down the bottom here minus the smaller numbers up here. Alright, 15x. We did this part already. This 15x minus this 15x gives 0x. X is eliminated. Alright, plus 21y down here minus the 10y up here gives 11y equals, then the 93 down here minus the 60 up here gives 33. Now with x gone, we can just work with the y. 11y is equal to 33. Let me put the y part in green. So 11 times what gives you 33? It's 3. So y must be 3. 11 times 3 gives you 33. So therefore y equals 3. Or we could have just said divide by 11, divide by 11. 11 cancels 11. 3 into 3, 11 into 11, 1. 11 into 33 goes 3. So y is equal to 3. So we know that y is 3. Let us look at how we find x now. Let's put the value for y in one of these equations. We substitute y is equal to 3 in equation. Which one should we use? Alright, let's use equation 1. Equation 1, because it seems to have smaller numbers, easier to work with in equation 1. Alright, so we have 3x plus 2y, but y is 3, so it's 2 by 3. 2 times y means the same as 2 by 3 because y is 3. Equals 12. Alright, 3x plus 2 3s is 6 equals 12. Okay, now let's remove the 6 and then remove the 3. How we remove the 6? Subtract 6. You minus 6 minus 6 minus 6 from both sides. So what we have is 3x, 6 minus 6 is 0, that's gone, equals 12 minus 6 is 6. Then 3 times what gives us 6? 3 times 2 gives us 6, so x must be 2. Or you could say divide by 3 to get rid of 3. You have x equals divide by 3, 3 into 6, 2. So x equals 2, y equals 3. Okay, so that's it for that example. We'll do another example next time.